Welcome to my algebra class. We're in Chapter 9, Section 2. This is the second method of solving a system of equations. It's called substitution. This is where we have two equations. We take one equation and solve it for one variable. Then we put that into the other equation and solve for the remaining variable. And what happens is we eliminate one variable and we figure out what the other one equals, and then we can substitute it back in and find the first one. I'm going to show you how to do this with from an example from the internet, and then we'll do these two problems here.
So we're going to solve this system of equations by the substitution method. Step one is that we solve one of the equations for one of the variables, but that's already done for us since this equation says 3x plus 1 equals y. It is solved for y. Next, I'll substitute that into the second equation, where y is in 2x plus 3y equals 25. I put 3x plus 1. So instead of having 3y, I have 3 times 3x plus 1. Next, I take that equation and solve for x. I'll use the distributive property to get rid of these parentheses. 3 times 3x is 9x, and 3 times plus 1 is plus 3. Now I have the equation 2x plus 9x plus 3 equals 25. I'll combine the like terms, 9x and 2x. That makes 11x. Now my equation is 11x plus 3 equals 25. I subtract 3 from both sides of the equation, so 11x equals 25 minus 3, 22. I divide both sides of the equation by 11, and I get x equals 2. In step 4, I'll take x equals 2 and substitute that into the equation 3x plus 1 equals y, and that gives me 3 times 2 plus 1 equals y. 3 times 2 is 6. 6 plus 1 is 7, so y equals 7.
Okay, we'll do these two problems and then start the evens. This one here, I would take this equation and solve it for either x or y. Let's just do x. So x plus y equals 10. I would subtract y, get it on the other side, so negative y plus 10. Now I'm going to put this into this equation. So where I see x, I'm going to replace it with negative y plus 10. Plus 2y equals 10. Now I have an equation just in y. Using the distributive property, I get negative 3y plus 30 plus 2y equals 10. Negative 3y and 2y make negative y plus 30 equals 10. Subtract 30 from both sides. I get negative y equals negative 20, so y is 20. Then I'm going to plug it back into this equation here. So x equals negative 20 plus 10, which equals negative 10. So my ordered pair that works is x is negative 10 and y is 20. And I could plug that back in and make sure that it does work. So negative 10 plus 20 is 10. And 3 times negative 10 is negative 30, plus 2 times 20, 40, that makes 10. This one is a little bit easier because I can see the m's by itself, so I don't have anything. That would be the one I would solve for. So m equals, add 4n to both sides, 4n plus 6, and then I would put this in for m. So I get 2 times 4n plus 6 minus 8n equals 6. Distributive property gives me 8n plus 12 minus 8n equals 6. The 8n and the 8n cancel out, and I get 12 equals 6, which is a false statement, so there's no solution. These lines must be parallel. So if you get no solution, they're parallel. If you get an identity, then they're the same line. So we're ready to do the evens on 419, 1 to 20, and then 31 to 33. So problem number 2. Paper's headed, skip a line, title, folded in half. Number 2, we're solving these all by substitution. We have y equals 2x and 5x minus y equals 30. Since this is already solved for one variable, we're just going to put it in over here. So where I see y, I'm going to substitute in 2x. That's why it's called the substitution method. And 5x take away 2x is 3x. Divide both sides by 3, and I find out that x is 10. And then we plug it back in here, substitute it back in. 2 times 10 for x, and y is 20. So the ordered pair, be sure you write your answers as ordered pair, was x, y. So the x goes first, 10, 20. You might want to put your variables above there so you make sure you get them in the right order. Problem number 4, we have m equals 4n and 3m minus 2n equals 20 is the other equation in our system. This one's already solved for one variable, so we're going to plug it in, substitute it in here. So where I see m, I'm going to put 4n. Multiply, I get 12n minus 2n equals 20. Collecting like terms, 10n equals 20. Divide by 10, and I have n equals 2. I have the value for n, so I'm going to plug it back in, substitute it back in here. So 4 times 2 is 8. So m is 8. My ordered pair is m, n, alphabetical order m, n. So m is 8 and n is 2. It is wrong if you get them in the wrong order, so be careful. Problem number 6. C equals 3d minus 4 and c plus d equals 16. We still have one of these equations solved for one variable, so we'll plug this in for c or substitute it in. So c becomes 3d minus 4 plus d equals 16. Collecting like terms, 4d minus 4 equals 16. Solving for d, we add 4 first. So we get 4d equals 20. Divide by 4. And the value for d is 5. Substituting it back in here, we get c equals 3 times 5 minus 4. 3 times 5 is 15. 15 minus 4 is 11. So our ordered pair is c, d, and it's going to be 11, 5. Problem number 8, we have 3a equals 2b minus 6 and a equals b minus 1. I'm going to use the second equation since it's solved for a. Substitute it in over here where I see a. So 3 times b minus 1 equals 2b minus 6. Distributive property gives me 3b minus 3 equals 2b minus 6. I'm going to get the variable on one side. I'm going to subtract 2b to keep things positive. So I have b minus 3 equals negative 6. Add 3 to both sides. I get b equals negative 3. And then substituting negative 3 in for b here, I get a equals negative 3 minus 1, so a equals negative 4. The variables are a, b, so alphabetical order a, b. A is negative 4, b is negative 3, so here's my answer. This ordered pair will solve both systems. Problem number 10, we have 3n plus 5m equals 7, and m minus 4n equals 6. I would solve for m in this one here because I don't have a number in front of m except 1. So m equals, add 4n to both sides, 4n plus 6. I use this for m, substitute it back into the other equation, 3n plus 5 times 4n plus 6 equals 7. Use your distributive property, you get 20n plus 30 equals 7. Collecting like terms, we have 23n plus 30 equals 7. Solving for n, subtract 30 first from both sides. And we get 23n equals 23. Divide by 23. That's a negative 20. Negative 23, so n equals negative 1. Substituting negative 1 back in here, we get 4 times negative 1 plus 6. That's negative 4 plus 6, so m is 2. And our ordered pair is m, n, so 2, negative 1. Problem number 12. We have 3y minus x equals negative 9 and 2y plus 5x equals 11. Solving for x would be easiest right here. So I subtract 3y from both sides, so I get negative x equals negative 3y minus 9. Multiply by negative 1, and I get x equals 3y plus 9. So now I have the value for x that I can substitute over here. So 2y plus 5 times 3y plus 9, the quantity, equals 11. Distributive property gives me 15y plus 45 equals 11. Collecting like terms, I get 17y plus 45 equals 11. Solving for y, subtract 45 from both sides. I get 17y equals 34, negative 34. Divide by 17, and y is negative 2. Substituting that back in over here, I get 3 times negative 2 plus 9, so x is negative 6 plus 9, which is positive 3. So our ordered pair is x, y, and x is 3 and y is negative 2. Problem 14. We have 3x plus 2y equals 11, and x minus 2 equals negative 4y. I'm going to solve for x here. So x equals, add 2 to both sides, negative 4y plus 2. Substituting this in for x in the first equation, we get 3 times the quantity negative 4y plus 2y equals 1. Distributive property gives me negative 12y plus 6 plus 2y equals 1. Collecting like terms, I get negative 10y plus 6 equals 1. Solving for y, subtract 6 from both sides, I get negative 10y equals negative 5. Divide by negative 10, and y is 1/2. It should be negative 1/2. Where did I make my mistake? All right, I found it. This should be 11. So y is negative 1/2. So x equals negative 4 times the negative 1/2 plus 2. 1/2 of 4 is 2. Negative times negative is 2. So I get 2 plus 2, which is 4. So the ordered pair is x, y, and x is 4, and y is negative 1/2. And that's my ordered pair. Problem number 16. We have 3x plus 2y equals 550. And x equals 4/5 y. I'm going to solve for x, so I'm going to substitute that in over here. So 3 times 4/5 y plus 2y equals 550. So that's 12 over 5y plus 2y equals 550. I'm going to multiply everything by 5, get rid of the fraction. So I have 12y plus 10y equals 2,750. Double check and make sure I did that right. And then that adds up to 22y equals 2,750. Divide by 22, and y equals 125. And then substitute it back here, 4/5, x equals 4/5 of 125. 5 was 125, 25 times, so x is 100. So the ordered pair is xy, x was 100, y was 125. So the ordered pair that solves the system is 100, 125. Number 18, y over 2 minus x equals 1. And then we have x plus y plus 7 equals 0. Well, we could solve this one for x. It really doesn't matter. So I would subtract y over 2 from both sides. And then multiply by -1, so x equals y over 2 minus 1. Substituting that in for x, I get y over 2 minus 1 plus y plus 7 equals 0. Multiply everything by 2, and I get y minus 2 plus 2y plus 14 equals 0. Collecting like terms, I have 3y. -2 plus 14 is 12 equals 0. Solving for y, subtract 12 from both sides. I get 3y equals -12. And then divide by 3, and y equals -4. Substituting that back in here, -4 divided by 2 minus 1, that's -2 minus 1, x is -3. Ordered pair is x, y, x is -3, y is -4. And problem number 20. We have m over 3 plus n over 3 equals 2. And 2m plus 3n equals 10. I'm going to multiply this by 3. And I get m plus n equals 6. Solve for m. M equals, subtract n from both sides, -n plus 6. Substituting it in, I get 2 times -n plus 6 plus 3n equals 10. Distributive property gives me -2n plus 12 plus 3n equals 10. Collecting like terms, I have n plus 12 equals 10. Subtract 12, and I have n equals -2. Substitute that back in here. The opposite of -2 is 2. And 2 plus 6 gives me 8. So my ordered pair is m, n, and m is 8, and n is -2. And then the last two problems, or you have 31 through 33, and the directions for those. Determine whether each of the following systems has no solution or infinitely many. If there are infinitely many, give 3 of them. So either you're going to get a false, when you solve it, you're going to get a false statement, which means there's no solution. And if you get a true statement, there's infinitely many, and you've got to give me at least 3 of them. So number 32, we have 3y minus 6x equals 24, and 8 plus 2x equals y. Well, it's already solved for y, so we'll go ahead and put in 8 plus 2x where we have y over here, minus 6x equals 24. Distributive property gives me 24 plus 6x minus 6x equals 24. So 24 equals 24. So there's an infinite amount. And we just got to come up with 3 of them. I'm just going to use this equation here and do that little chart. So if x is 1, then y would be 10. If x is 1 times 2 is 8 plus 8 is 10. If x is 2, then y would be 12. If x is 3, y would be 14. So there are my ordered pairs, since they're the same equation. That concludes the evens. Be sure and check the back of the book for the answers to the odds.